Have you ever been blinded by oncoming traffic? Well, it poses a serious problem and we're here to solve it. I'm Preston Allender.
I'm Tyree Franklin.
And I'm Samuel Montoya.
And this is our EDD Project Nightside. Starting off with our problem statement, research found that up to 15% of all automobile car crashes occur as a result of high beam glare each year from approaching traffic, according to the National Library of Medicine. Continuing on to what interested us in this project, for our connection, or at least my personal connection, to start off with my uncle and cousin, they were both in extremely bad car crashes. My uncle Jeremy said he was extremely tired and distracted by headlights. He ended up rearing off the road. And my cousin Lisa drove straight into a pole after being distracted by headlights. She said it was pretty bad and her car was totaled as well. This leads us to our driving question. We wanted to ask ourselves, how can we reduce the impact of oncoming headlight glare to create a safer nighttime driving environment? Continuing on to the issues that we wanted to discuss about the project, we wanted to look into what is actually caused by nighttime driving and headlight glare. We found that driving while distracted is oftentimes caused by headlight glare because people can't end up seeing on the road. We also found that unsafe driving practices are highly caused by headlight glare because it makes it harder for people to see on the road and see things that they need to see. And we also found that we wanted to help people with glare disability or people that experience glare disability. We wanted to help and solve that problem as well. This leads us to what you're missing on the road. We found that oftentimes people who experience headlight glare and are blinded by it, they end up missing traffic such as other cars on the road, obstructions such as objects, animals, and pedestrians on the road, and other warning signs or essential warning signs for safety such as stop signs, yield signs, and stoplights as well.
Now on to where these issues occur. There are three environments where these issues are pretty common. We have back roads, highways, and residential areas. Back roads, these issues are very common mainly because the roads can have very sudden glares, increasing distraction for the driver almost immediately at night. Then we have highways where drivers are exposed to these high beam conditions at high speeds. And then we have residential areas where the drivers have to drive with blinded with surrounding pedestrians and objects and street signs as well. Now, there's three demographics that are affected by nighttime driving. We have the everyday driver who may not have much experience with driving while being blinded, but they have to drive in these conditions occasionally. Then we have a late shift worker. These drivers often are forced to drive at night, but ultimately we have truck drivers who have to drive large vehicles and semi-trucks but are subject to do this for long hours.
Moving on to our research. So when do most of these fatal accidents occur? We can see here that most of the fatal accidents occur at times of the day where they actually have less light. And while 53 may not seem like a large percentage, in the scheme of millions of drivers every year, it leads to thousands of accidents. Moving on to the development of products to prevent this over time. We can see in the 1920s there was the creation of the dual headlight beams, which actually switched manually between your high beams and your low beams. We can see in the 1930s there was the creation of the manual day and night rearview mirrors, which allows you to switch the refraction on your mirrors in order to prevent glare from your rearview mirrors. In the 1980s, we can see auto-dimming rearview mirrors, which did this automatically. Moving on to the 2000s, we can see the creation of the adaptive front lighting system, which, similar to the dual beam system, would just work automatically, switching between your high and your low beams. Then we can see in 2014 there was the creation of the matrix adaptive LED headlights, which would actually curve the beam around other cars. In 2016, we can see the creation of highly intensive laser headlights, which would produce more light but less glare. However, when looking at these, we noticed that many of these are preventive for others, but there's little to no protection for yourself.
Now onto our decision matrix. With seeing what's already out on the market, we can utilize a decision matrix, which is a fair grading system to compare different ideas, patents, and even products. With that being said, we have our patent solution matrix. Our patent solution matrix is where we compare unpublished designs that are already patented. But here you can see with our three designs, we have the top score with a score of 11, which is called the anti-glare hard-coated laminated film. But here are some takeaways from that. All of these designs, as previously mentioned, are unfinalized. They remain in the design phase for years out of hand. Then we have industry. They don't quite meet industry standards. For example, a lens hood that goes up and down onto the driver's windshield, which is not very ideal in the automobile industry, and a lot of these designs are quite insufficient. Now we have our marketplace solutions. We have 3 marketplace solutions, with the highest score being laminated film glasses. But here are some even more takeaways from this. They were all very similar. They all had some sort of film that would be applied differently. And with that being said, they lacked originality and authenticity. But then they were also expensive.
Moving on to a survey that we sent out. We wanted to ask people how distracting are these headlights to people in our community. And we found that most people found it to be at least sometimes distracting, with very few people actually finding it to be really distracting. So if it's such a big problem in our community, why is nobody trying to solve it? Well, we found that most people weren't aware of solutions, they haven't even thought about solutions, or there's no good solutions for them to use.
With taking that advice into note, we created 3 designs that we wanted to make. But let's go over them. We have Sketch A, with it being a circular film which would be very distracting on the windshield. Furthermore, it would utilize what's known as electrochromic film technology, which allows a laminated film to change its transparency and opacity when it's hooked up to some sort of power. With it obviously connected to an electric box, we can create a product that can turn on and off whenever we want it. However, having a circular film that is onto a windshield would be very distracting for the driver. So with that being said, it had a score of 11. Then we have a permanent film, which is already out on the market, so it wasn't very ideal. And we wanted to have that onto the windshield and cover up the entire windshield. However, that's not quite what we wanted yet. So with that being said as well, with a score of 13, now moving on to Sketch C, which combines both ideas for an electrochromic film that covers the entire windshield and allows us to alter the light transmittancy that is being put through the windshield and that is affecting the driver. Therefore, we have a score of 15 with our final technical sketch.
So we've been talking a lot about electrochromic film, but what exactly is it? In this demonstration here, you can see that electrochromic film is a film activated by electricity that changes its transparency when it receives this electricity. You can see in this demonstration that the light is actually refracted off while still letting in visible light. So moving on to our first stage in building, this is our mock-up prototype. And this stage was mostly supposed to be form over function, but we also wanted to heavily focus on the electronics to make sure that we got a head start. So going on to our actual building, what did we spend most of our budget on? You can see here that the most of our budget was spent on our actual film, our electrochromic film, which is the most vital part of our whole project, while still contributing some money to our electrical components, our iron connections, and so on. And you can see here that we actually went over our $200 budget, and this is because we required more resources that we weren't able to afford with our original budget that were either donated to us or we paid for out of our own pockets. Moving on to our digital mockup, this is kind of a visualizer of how we had our original electronics designed. You can see here that we used a sensor in order to send a signal to the Arduino that would automatically regulate the electrical output that would be used for the smart film.
Now onto our electronics diagram. Here you can see our electronic schematic. It looks a little bit complicated, but ultimately it has 5 light sensors, which will be put through the brains of our product, which is also the Arduino Uno, which will be pushed out from that chip onto what's known as an N MOSFET channel, which allows us to turn the film on or off. Essentially, when we're applying onto the windshield, it would basically be when the film blocks the light or is not blocking light, and then we hook that up to a 24-volt battery, which is what powers up the electrochromic film.
Moving to our prototype building stage, we knew that the electronics were going to take us the longest from our mock-up prototype, so we wanted to get a jump start on that and start with those at first. And then moving to our second stage, we wanted to do the film activation. This was actually our first big milestone into the project on our prototype building. We found that it was extremely easy to get this on and working, and we wanted to continue on with that. We also found that we were moving to our last stage of combining both. We found that was the easiest stage for us, as all we had to do was solder both components together and get each of them working. This leads us to our final prototype. On the right, you can actually see our electronics box. On the top, you can see our breadboard with all of our sensors and our batteries as well. And then on the bottom contains our Arduino Uno and our MOSFET as well. And then on the right side, you can actually see a final full view of our prototype. On the left, you can see our electrochromic film that's hooked up to our electronics box. And then on the bottom right of our full view, you can see our full electronics box that encases all electronics in a one completed box.
Now onto the installation process for our product. We have three main phases for this. We have a processing unit, which is essentially our electronic box, which is all the code, the brains, the chips, in order to power our electrochromic film. Then we have our power source, which would essentially just be a cigarette outlet hooked up to a car. And then we have our electrochromic film, which will be placed onto the windshield.
Moving on to how can we make sure this is safe for users to actually use? So these are our testing procedures. The first test we wanted to act on is the activation consistency. How consistently is it activating so that it doesn't confuse users or it's not too late? Then we wanted to move on light transmission just to make sure how much light is it letting in, is it actually being effective in its use? And then we also wanted to do a survey or a perceived effectiveness test, which is asking people, hey, would you actually use this? How well would this work for you? Does this change anything for you?
So first off, with our activation consistency test, we tested a total of 200 times specifically with this test. And it's essentially the test that will count how much time it takes for after the light is detected up to how long it takes to alter the electrochromic film. This whole process takes a total of 8 microseconds, and it did for the total of 200 tests on the spot, which is nearly 40,000 times faster than it takes for the average human eye to blink. Now we have our light transmission test, which is we tested 50 times, in which we tested how much light is being put through the film whenever it's on and off. So with that being said, we have a average range of from 31.12% all the way to 98.33% transmittancy rate. With that being said, our film has a median of 50.9%, which means that when light is going through our film, it has a very strong contrast balance, allowing for the film to take out all the unnecessary light with allowing the driver to see the road fully without being distracted.
Moving on to our perceived effectiveness test. When asking people how effective is this for you, most people said it would make a significant change to their driving, with still a large percentage saying it would make a minor, and very few people saying it would make no change or even though we're driving worse.
Now onto our reflection. As a team, I feel like I've learned how to manage and effectively manage the team's work as a whole, essentially mitigating how work is effectively managed throughout the team.
Moving on to communication. As a team, we learned how to timely, professionally communicate, making sure that we get our points across and our work done.
Moving lastly to our time management, we found that we often had to use our time better and we had to focus on the priorities of the project rather than focusing on what we wanted to do during the project. But
now on to our next step. For our product, we desire to have our film legally noted, which requires for us to have a legal grading for our film from a manufacturer in order to allow people to put this on their vehicles.
Next, we want to go on into improvement. How can we improve our product? The first thing we want to do is integrate our product fully into the car system, making sure that when third-party installation is done, that it actually has no extra things that need to be added, and it can just be directly installed into your car.
Lastly, we wanted to work with manufacturers to get this automatically into cars. That way people don't have to worry about blinding headlight glare and having to buy our product. That way it just comes along straight with the car. Here are our references. Thank you. Are there any questions?
That's good enough.